Hey there everyone, welcome back. So today we are discussing this question number 4 from chapter 8 Trigonometry, exercise 8.3. So this question number 4 is subdivided into 10 questions which we will be solving in parts, and here's the first question that asks us to solve this identity, that is cosecant theta minus cot square theta should be equals to 1 minus cos theta by 1 plus cos theta. So taking the LHS, that is cosecant theta minus cot theta whole square. This can be written as 1 by sine theta, as sine theta is the inverse of cosecant theta, minus cos theta by sine theta whole square. So as we can see that denominators are equal, we can just add them, that is 1 minus cos theta by sine theta whole square. That can also be written as 1 minus cos theta whole square by sine square theta. Now as we know the identity, sine square theta plus cos square theta is equals to 1, so sine square theta can also be written as 1 minus cos square theta. So this identity becomes 1 minus cos theta whole square by 1 minus cos square theta. So now we can see that this is in the form of a square minus b square, which can also be written as a plus b into a minus b, that is 1 minus cos theta whole square by 1 plus cos theta into 1 minus cos theta. And clearly from here 1 minus cos theta and square gets cancelled, and lastly we are left with 1 minus cos theta by 1 plus cos theta, that is nothing but equals to RHS, and hence we have verified this. Now with the second question, so we are given with cos A by 1 plus sin A plus 1 plus sin A by cos A, and we need to prove it as 2 into secant A. So take the LHS, that is cos A by 1 plus sin A plus 1 plus sin A by cos A. So it is a pretty simple one, so just cross multiply. This becomes cos square A plus 1 plus sin A whole square by 1 plus sin A into cos A. This can be further written as cos square A plus 1 plus sin square A plus 2 sin A by cos A plus sin A cos A. So cos square A plus sin square A becomes 1, as we know the identity that sin square A plus cos square A is equals to 1. So this becomes 2 plus 2 sin A, and cos A can be taken as common from here, and this becomes 1 plus sin A. Okay, and then you can just simply take 2 as common here, and this becomes 1 plus sin A, and we already have cos A into 1 plus sin A. So 1 plus sin A gets cancelled, and we get 2 by cos A, which can be further written as 2 into secant A, as we know that secant function is the inverse of cos function, and this is the required RHS. Now moving on to the third question, we are required to prove tan theta by 1 minus cos theta plus cot theta by 1 minus tan theta as 1 plus secant theta into cosecant theta. There is also a hint given, that is writing the expression in terms of sin theta and cos theta. So this question is a bit tricky one and a lengthy one too, but it's very important as an exam perspective. So let us just write down the LHS, that is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. And as we are asked to express everything in terms of sine and cos, this becomes sine theta by cos theta by 1 minus cos theta by sine theta plus cos theta by sine theta by 1 minus sine theta by cos theta, which can be written as sine theta into sine theta by cos theta into sine theta minus cos theta, and this can be written as cos theta into cos theta by sine theta into cos theta minus sine theta. So we can cross multiply them, and this will be something as, okay, let's write down this first, that is sine square theta by cos theta into sine theta minus cos theta plus cos square theta by sine theta into cos theta minus sine theta. And now let's cross multiply. This becomes sine cube theta minus cos cube theta by cos theta into sine theta into sine theta minus cos theta, as sine theta and cos theta minus cos theta are common in both the fractions. Now we know the formula of a cube minus b cube, that is equals to a minus b into a square plus b square plus a into b. So writing sine cube theta minus cos cube theta in this form, we get sine theta minus cos theta into sine square theta plus cos square theta plus sine theta cos theta, and we have the denominator as cos theta sine theta into sine theta minus cos theta, and from here sine theta minus cos theta gets cancelled, and the remaining terms can be written as sine square theta plus cos square theta plus sine theta cos theta by sine theta cos theta. And we know that sine square theta plus cos square theta is equals to 1. So this expression becomes 1 plus sine theta cos theta by sine theta cos theta, which can be divided into two terms, that is 1 by sine theta cos theta plus sine theta cos theta by sine theta cos theta. This gets cancelled, and this whole expression can be written as cosecant theta into secant theta, as cosecant theta is the inverse of sine theta and secant theta is the inverse of cos theta, plus 1, and this is the required RHS.